Section 3.2, Slope. Slope measures a line's steepness and direction. The slope is also called the rate of change and can tell us if the quantity being graphed increases or decreases and how fast the quantity is changing. The slope m of a line passing through 2 points, x sub 1, y sub 1, and x sub 2, y sub 2. Those are called subscripted variables. They are just using the subscript of 1 or 2 so that we can distinguish one from the other. The slope is defined to be the difference in the y values divided by the difference in the x values, where the x values cannot be equal to each other, because if they are equal to each other, we will have division by 0. So this is our equation for the slope of a line, and we will be using it often. Some people like to also think of the slope as rise over run. Looking at the graph, they want to think of it as rise over run. So a line rising to the right has a positive slope. We say that such a line is increasing because as x values get larger, y values also get larger. So the line is increasing. Find the slope of the line that passes through the points -2, 3, and 5, 6. Let's plot the points, sketch the line, and then determine what the slope is. We can use the formula. We can say the slope is the difference between the y values, 6 minus 3, divided by the difference between the x values, 5 minus a -2. That will give us 3/7. Notice that we can go the other way. We can take the difference between the y values beginning with the 3. We'll say 3 minus 6 over, let's take the difference between the x values beginning with the number 2, -2 minus 5. That gives us -3 over a -7, which is still positive 3/7. We get the same value no matter which point we start with, but if we begin with the 3, we have to begin with the -2. If we begin with the 6, we have to begin with the 5. So you have to go in the same direction. We can calculate slope using the graph. We can take the rise, count the blocks, 1, 2, 3, over the run. How many blocks are there? 7. Looking at the line, we know that the slope is positive. We don't have to write the positive, but I'm doing it for emphasis. Positive rise over run, 3/7. So we get 3/7 no matter which way we do it. A line that is falling to the left has a negative slope. We say that such a line is decreasing because as x gets larger, y gets smaller. Find the slope of the line that passes through the points -1, 1, and 2, -1. Plot the points, draw the line. My line doesn't always go through my points. Then we want to calculate the slope. We can do that with our formula. We'll subtract the y values, -1, -1, over the difference between the x values, 2 minus the -1. That gives us a -2 over a positive 3. So our slope is -2/3. Going from one point to the other, the slope is The line is going downhill, it's decreasing, so we know that our slope is negative. We want the rise of 2 over the run of 3. So looking at the graph, we can also tell that our slope is negative 2/3. When the slope of the line is 0, that's a horizontal line. The slope is 0. When the slope of the line is undefined, it is a vertical line. Undefined slope. I've had some students tell me that I'll ask them what is the slope of the line, and they'll say there's no slope. I ask them what they mean. Half the time they'll tell me, oh, that means the slope is 0. The other half of the time they'll tell me, oh, that means the slope is undefined. Well, no. You can't say no slope means both of those. They're different things. So I will not allow students to answer that there's no slope. I need to know, is the slope 0, as in a horizontal line, or is the slope undefined, as in a vertical line? You can't say there's no slope, because I don't know what that means. What is the slope of the lines pictured in the following coordinate plane? Our first line is a vertical line. So what is the slope? It's undefined. Pick 2 points on the line. This is the point 5, 0. And how about the point 5, negative 2? If we use our equation for the slope, we could say negative 2 minus 0 over 5 minus 5. Notice that our x values are equal. That gives us division by 0, and that is undefined. That's why a vertical line has undefined slope. Horizontal line, we said that for a horizontal line, the slope is 0. Pick 2 points on our horizontal line. Here's the point negative 5, negative 4. And here's the point 0, negative 4. Notice the y values are equal there. So when we calculate the slope, we might take negative 4 minus the negative 4 over negative 5 minus 0. That gives us 0 over a negative 5. 0 in the numerator, not a problem. The answer is 0. Vertical lines, undefined slope, causes division by 0. Horizontal lines, the slope is 0 because you have 0 in the numerator. Find the slope of the given lines from the graph. Our first equation, we're looking for 2 points, any 2 points. Look at all the points where the line is crossing the grid of the graph. We want the 2 points where the line most exactly crosses the intersection of that grid. I like this point. It seems very much to be where the graph is crossing the grid. And this point, we want to know the slope. We can create a right triangle. We can look at the rise and the run. Just count the boxes. 1, 2, 3, 4, 5 is the rise. 1, 2, 3 is the run. The slope can be thought of as the rise over the run. This line is going uphill, so that slope is positive. Our next example, we first identify 2 points, any 2 points, where the line seems to be crossing exactly at an intersection of the grid. We want points that have x and y coordinates that are integers. This line is going downhill, so we know that the slope is going to be negative. the rise, count the boxes, 4, the run, 2. So negative 4 over 2. So our slope this time is negative 2. Sketch the line that passes through the point 1, negative 2 with slope 3. So let's start with the point 1, negative 2. Now we need to have a slope of 3. I want to think of that slope as 3 over 1 because I like to think of the slope as the rise over the run. So if we start at a point, any point on the line, and we rise by 3, 1, 2, 3, it's positive, so we know it has to go uphill. So we're going to run by 1. Rise by 3, run by 1. And that will get us our next point on the line. So starting at this point, 1, negative 2, we rise by 3, we run by 1. That gets us our next point. We can rise by 3 again, run by 1, to get another point. We can do it again. Rise by 3, run by 1. We can even go down by 3 as long as we go to the left 1, down 3, to the left 1. So all of those points fall on our line. And if I was able to draw a straight line, you would see that all those points fall on a straight line. Sketch the line that passes through the point negative 4, 5 with slope negative 2/3. So we'll start by plotting the point negative 4, 5. Now, we have a slope of negative 2/3. I like to think of slope as rise over run. Overall, we know this line is going downhill. So if we start at one point and we think about going down by 2, we could go to the right by 3, and that would give us our next point. We could also start at a point and go up by 2 and left by 3, and that will also give us our next point. So let's try it both ways. Let's start at this point, negative 4, 5, and first we're going to try going down 2 over 3. Here we are at our next point, negative 1, 3. But let's start at that point, negative 4, 5 again, and this time let's try going up by 2, left 3. See how our points line up? So we can begin at a point, and if our slope is negative 2/3, we can go down 2, right 3, or we can go up 2, left 3, just as long as you make sure that your line is going downhill. Your line needs to be decreasing. Let's plot the point 1, 3. Undefined slope. What kind of line has undefined slope? A vertical line has undefined slope. So we want to draw a vertical line through that point 1, 3. 2 vertical lines are parallel. Parallel means they will never intersect. They both keep going up forever and down forever. They never intersect. They're parallel. 2 non-vertical lines are parallel if and only if their slopes are equal. That is, if the slopes are m1 and m2, then m1 equals m2. 2 non-vertical lines are perpendicular. perpendicular lines intersect and create four 90-degree angles. We can represent a 90-degree angle by writing 90 degrees, or we can use our little box in the corner, and that means it's a 90-degree angle. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. That is, if the slopes are m1 and m2, then m1 times m2, that's their product, and that product has to equal -1. A line has a slope -2. What is the slope of the line parallel to this line? Parallel, same slope, -2. A line has a slope of -2. What is the slope of the line perpendicular to this line? So -2 times whatever our second slope is, if we multiply them together, we need to get -1/2. What is m2? What is our second slope? +1/2. You could say that the slopes of perpendicular lines are opposite reciprocals. If one slope is positive, the other is negative. Whatever the one slope is, the other is the reciprocal of that slope. Opposite reciprocals. Consider the points 3, 2, 5, 1, and -3, -2, and 1, -5. Are lines AB and CD parallel? If they're parallel, then their slopes must be equal. So we need to find these two slopes. Let's find the first slope. From A to B, we want to find the difference in the y values over the difference in the x values. -1/2. -1/2 is our first slope. Now let's find our second slope, the difference in the y values, -5 minus a -2 over 1 minus a -3. -5 minus a -2 is -5 plus 2, -3. 1 minus a -3 is 1 plus 3, 4. Are these slopes the same? They are not. So these lines are not parallel. No, they are not parallel. Determine if BC and CD are perpendicular. If they are perpendicular, then the slope of the first line and the slope of the second line, their product will be -1. Their slopes will be opposite reciprocals. So let's calculate the slope of the first line. We need the difference in the y values, 5 minus 2, over the difference in the x values, 3 minus 1, 3/2. That's our first slope of the line connecting points B and C. How about the second slope, the slope of CD? Let's take the difference in the y values, 2 minus 0, over the difference in the x values, 1 minus 4. That gives us 2 over a -3. So let's take those two slopes, 3/2 times -2/3 If you multiply those, do you get -1? Yes, you do. These lines are perpendicular. Also, you may notice that the slopes are opposite reciprocals. One is positive, one is negative, and you take the reciprocal of 3/2 and you get 2/3. So those lines are perpendicular. Suppose you are traveling by car on spring break. At 3 p.m., you have traveled 160 miles. At 6 p.m., you have traveled 340 miles. On a coordinate plane, label the axes and then plot the appropriate points. So, what I'd like to do here is I would like to decide whether to put time on the x-axis or the y-axis. Which one is the independent variable? Does time depend upon the number of miles you've traveled? Or would you say that the number of miles you have traveled depends upon how long you've been driving? I think miles depend upon time. So we put the independent variable, time, on the horizontal axis, and we put our dependent variable, distance, on our vertical axis. And our distance will be measured in miles, and we can put our time in hours. So we can have, let's skip over 2 blocks for 1 p.m., 2 more for 2, 3, 4, 5, and finally 6. Our distance, we have 160 miles that we need to record, and we also have 340. So how about we let 3 blocks be 100? 200, that one's 300, and then the top one is 400. So we need to plot the point 3, 160. 6, 340. Let's connect those 2 points with a line and compute their slope. So, I don't think I can do rise over run with this graph because these points are not exactly on the grid, so it's hard for me to count blocks. Let's use the formula. We have 2 points. We have the point 3, 160. And we also have the point 6, 340. So let's find the difference in the y values. 340 minus 160. Looking at the graph, we already know this slope is going to be positive. 340 minus 160 is 180. 6 minus 3 is 3. Let's talk about units a little bit. That numerator is the change in the y value. That's distance measured in miles. The denominator is the change in time, so that's time measured in hours. 180 divided by 3 is 60. And notice that's measured in miles over hours. How many miles can you travel in 1 hour? So the slope, 60 miles per hour. Interpretation, speed. Miles per hour gives us speed. That's the speed of the car. Suppose the following graphs represent the number of people with bird flu over a period of time in a remote village. For each scenario, state whether the slope is positive, negative, or 0. What does it mean in terms of this problem? Number of sick people, time. What's happening in our first graph? As time goes by, the number of sick people is decreasing. We have a negative slope. M is less than 0. What does that mean in terms of what's happening in the village? We had bird flu. We started off with quite a few sick people, but over time, what happens? The number of sick people decreases and decreases until there are no more sick people. So what happens in terms of sick people in the village? Eventually, there are no more sick people. It doesn't really tell us if those people died or they got better, but eventually there are no more sick people. In our second situation, the number of sick people starts off, and then over time it increases. It keeps getting bigger and bigger. M is greater than 0. A positive slope because the number of sick people is increasing. What does this mean in terms of the village? They've got problems. The number of sick people is increasing. It looks like eventually everyone in the village is going to get sick. Everyone's going to have the bird flu. So the number of sick people keeps increasing. They have serious, serious problems. Finally, in our third drawing, the number of sick people starts out at a certain amount, and it stays right there. The slope is 0. The number of sick people it's not changing. So, a certain amount of people started off with the bird flu. We don't know if it's the same people, but you have the same number of people. The same number of people continue to have the bird flu. It doesn't get better, doesn't get worse. It stays the same. The same number of people are sick. So which village would I rather live in? I want the number of sick people to decrease. I hope they didn't die, but that's the village I want to be in. And I really don't want to be in that village, because everybody in that village is going to be sick eventually. That's it for this section.